Metallurgy, the entire process involved in the extraction of pure metal from its ore, is called metallurgy. Terms used in metallurgy: ore and mineral. These are the naturally occurring forms of metals from which metal can be extracted. Ore is that form of metal which contains a higher percentage of metal compound, and metal can be extracted conveniently and economically from it. In minerals, the percentage of impurities is high, so that metal cannot be extracted economically from it. In ore and minerals, the metal compound is associated with some impurities. These impurities are called matrix. To remove matrix chemically, some outer chemicals are added to the ore. These chemicals are called flux. Flux combines with matrix to form a fusible mass, and this fusible mass is called slag. Matrix plus flux is equal to slag. Metallurgy of aluminium. Aluminium is a very reactive metal, so it never exists in free state. It always exists in combined state. Its main ores are bauxite, cryolite, and corundum. Extraction of aluminium from bauxite ore. It can be divided into two steps. In the first step, bauxite ore is concentrated, and in the second step, concentrated bauxite ore is converted into pure aluminium. Bauxite is a mixture of Al2O3.2H2O along with ferric oxide and silica as impurities. Concentration of bauxite ore by Bayer's process. In this process, powdered and pulverized bauxite ore is mixed with a concentrated solution of sodium hydroxide, when all aluminium present in bauxite gets converted into sodium metaaluminate. Ferric oxide and silica do not react with sodium hydroxide because they are not amphoteric in nature. Sodium metaaluminate obtained is soluble in water, so it can be separated by filtration. The filtrate is mixed with water and heated to a temperature of 50 to 60 degrees Celsius, when it gives a white precipitate of aluminium hydroxide. This white precipitate is filtered, washed, and heated to a higher temperature of around 1100 degrees Celsius, when it decomposes to give Al2O3, which is called alumina. So in this way, bauxite is converted into alumina. In the second step, alumina is reduced to get pure aluminium. Alumina is reduced electrolytically. It is not reduced by the conventional reducing agents because the bond between aluminium and oxygen is very strong. For its reduction, Hall-Hérold's process is used. The apparatus used for this process is: there is an iron tank which is lined with an insulating material, and this acts as electrolytic tank or voltmeter. On the inner wall of this electrolytic tank, a gas carbon lining is applied which acts as cathode. A number of graphite rods immersed in the electrolyte act as anode. Electrolyte is a mixture of alumina, cryolite, and fluorspar in a ratio of 1:3:1. Alumina is never reduced alone because melting point of pure alumina is 2050 degrees Celsius and melting point of aluminium is 660 degrees Celsius. If we reduce alumina alone by heating to such a high temperature, most of the aluminium obtained gets vaporized. So it is mixed with cryolite and fluorspar. Cryolite and fluorspar bring down the melting point of alumina to 950 degrees Celsius. Cryolite increases the conductivity of the solution and fluorspar increases the mobility. The reactions taking place during the reduction of alumina are: first, all the components of the electrolyte will dissociate to form their ions. We have aluminium, sodium and calcium ions. These ions move towards opposite electrodes. So all cations will move towards cathode and anions towards anode and get discharged as per the selective discharge of ions. At cathode, aluminium gets discharged to form pure aluminium, and this aluminium seeps down because the temperature is high, and with the help of the sloping bottom it moves down and can be collected with the help of tap outside. At anode, oxide ions get discharged. So two oxide ions combine to form oxygen molecule, and this oxygen molecule reacts with carbon, which is the carbon of graphite anode, and it forms either carbon monoxide or carbon dioxide. In this way, the size of anode gradually decreases because it is getting evolved in the form of carbon monoxide and carbon dioxide. Therefore, graphite anodes need to be replaced periodically